네, 안녕하세요. 요번에는 제가 직접 판서를 해가면서 진도를 나가겠습니다. 알겠지만 제가 원래 노트에 있는 거를 가지고 하면 진도가 너무 빨리 나가가지고 가끔 가다가 제가 판서를 하면서 하겠습니다. 그래서 오늘은 우리가 대신에 이제 노트는 없어요. 여러분들이 다 필기를 해야 됩니다. 오늘 증명할 내용은 뭐냐 다음과 같습니다. Suppose that 이제 함수 fz라는 게 이제 요거를 여러분 이제 실수 부분, 실수 파트 plus I v x y. So this complex part, imaginary part here z equals to x plus I y. So x and y are real number. Okay, and also let and z0, let's call z0 equals to x0 plus I y0, and then we called u0 equals to u w0. So let's say this is w0 equals u0 plus I v0. Here x0, y0, u0, v0. These are all real number. Okay, then what you can show is this limit z converge to z0, z converge to z0. Now you compute the f of z equals to w0 if and only if then see the limit here, this one converges to u0. So limit here x comma y converges to x0 y0 and u xy equals to u0 and limit x comma y approaches to 0 comma 0 v xy converges to v0. So that's what we need to prove. Okay, well, let's try to prove this one. So first we prove this part. Okay, so then suppose that we assume that the limit z approaches to z0 and fz minus equals to w0. So okay, by the way, then what? So I will claim what? So we need to show this one. So limit x comma y approach to x0 y0 u xy equals to u0 and limit x comma y approach to x0 y0 v xy converge to v0. So if we like to show this one by definition, so by definition you need to show for this guy corresponding to, for every given epsilon you have to find the delta is positive such that the distance between these two, so the root 2 x minus x0 squared y minus y0 squared, this is less than delta, greater than 0. Whenever this is true, then you can ux comma y minus u0 is less than epsilon. That's what we need to show, right? Okay. Also, this is the same thing. This is the same thing too. For this one, you need to show for given epsilon, there exists delta such that the same. Okay, you replace v by u by v. So then I don't need to copy again. So I will. Okay, so how do I show this one? So this is our claim. This is our claim. Two of them. And also we need to vxy minus v0 is less than epsilon. So okay, so well, so in order to prove this one, so you always start with let epsilon is positive given. Okay, we given. Then we assume that the limit of f of z converges to z0 equals w0 by definition. So since limit z converges to z0, f of z equals w0, w0. So given epsilon, so there exists the delta such that z minus z0 is greater than 0, less than delta. Whenever this is true, f z minus w0, this one is less than epsilon. Okay, this is by definition, since the limit of f of z converges to z0 equals to w0. Just you look at this part very carefully. So you compute this guy is root 2 x minus x0 squared y minus y0 squared, right? And look at this part. So you look at this part, this is exactly root 2 u xy minus u0 squared v xy minus v0 squared. So you have this one. Okay, so eventually we proved everything. We proved already. So from here, so this guy is greater than u xy minus u0 modulo, no, absolute value, right? Because this one plus this one, and also this is greater than or equals to absolute value of v x comma y minus v0 absolute value. Okay, so then I can, from here you obtain this. So I obtain this one, just rewrite. So whenever this is true, then this guy is less than epsilon, this guy is also less than epsilon. So that implies whenever 0 z minus z0 is less than delta, we have u x comma y minus u0 is less than epsilon, v xy minus v0 is less than epsilon. So that implies what? Limit x comma y approaches x0 y0 u xy converges to u0. The limit x comma y approaches x0 y0 v xy converges to v0. So we are done. So this part is by definition we are done. Okay, so let me prove the other way around. Okay, this part. For this part, you assume that this. Okay, you assume this one, and you assume this, and what we need to show is this one. Okay, so we need to show this. Okay, so let's call this is star. I'm not gonna copy again. So assume star. Okay, so then our claim. So we need to show the limit z approaches z0 f of z equals w0. That's what we need to show, right? So we assume this part, we assume this one. So we assume this one, we need to show that. Okay. So here z equals x plus iy, z0, x0 plus iy0, w0 equals u0 plus I v0. Wow. So the claim is this. That is to show that for every given epsilon, you must find the delta such that 0 z minus z0 modulus less than epsilon delta. Whenever this is true, f z minus w0 is less than epsilon. Okay, so we have to show this one. So let epsilon positive be given. Okay, then since this is true, so then there exists. So delta 1 positive such that root x minus x0 squared y minus y0 squared. So this is greater positive less than delta 1. Whenever this is true, uxy minus u0 is less than epsilon, but I use a smaller one, so epsilon over 4. It's okay. You can use epsilon over 5 or 6, 7, whatever you want works. Okay. And this is because of the limit x comma y 0 x0 y0 u xy. Let me, so I don't need to copy again. So that's because here this is true. We assume this part, right? Okay. And also we have this part. We assume that part. So then there exists. We have also there exists delta 2 positive such that 0 greater than root x minus x0 squared y minus y0 squared less than delta 2, then v xy minus v0 module epsilon value epsilon over 4. So we have this statement. Okay, now, well, this is the same as that. Okay, so then what? Then let's take set delta equals to smallest one. So let's delta to be minimum of delta 1 and delta 2. So when you put this one is delta, then what? So then if 0 root x minus x0 squared y minus y0 squared, so this is less than delta, but eventually you compute this part, this is exactly z minus z0 modulus. Okay, z minus z0 modulus. So then when this is less than delta, then this is less than delta 1, also less than delta 2, right? So then this works, this one works at the same time. So then because of that, this is less than delta 1, we have v xy minus u0 is less than epsilon over 4. At the same time, vxy minus v0 is less than epsilon over 4. Okay, so from here, what you compute, let's compute f of z minus w0. What is it? So this is square root u xy minus u0 squared v xy minus v0 squared. Okay, squared. And this is both root less than epsilon over 4 squared. So this one epsilon over 4 squared, right? 4 squared. So this is root, what is it? 16 over 2 epsilon squared. Okay, obviously you can see this is less than epsilon. Okay, you have like 8 epsilon over 8, then epsilon over 2 root 2, so it's absolutely less than epsilon. So finally we are done. So here, so what do I have? So look at this one. Given epsilon, there exists a delta such that when this one is less than delta, then this guy less than epsilon. So we're done. Okay, that's how you prove. So we prove the theorem. Yeah. And then you can also prove the properties. So another theorem in the textbook, and suppose that the limit z approaches to z0, f of z equals to w0, and limit of f of z, another big F of z approaches z0. Suppose this one converges to w0. Okay. 자, fx는 w0로 수렴을 하고 라지 fx는 이제 라지 w0로 수렴한다고 합시다. 그럼 여러분 이제 그 극한에서도 배워서 알겠지만은 이제 이렇게 되면은 첫 번째 우리가 뭘 증명할 수가 있느냐, 리미트 z가 z0로 갈 때 요게 fz 더하기 라지 fz 요 계산하면은 이제 각각으로 갈라진다는 거요. 네, 이게 w0 이렇게 된다는 소리입니다. 그 다음에 두 번째 곱하기도 어떻게 되느냐, 리미트 z가 g0로 갈 때 곱하기도 각각이 존재하면은 곱하기도 이렇게 각각으로 곱하기로 하면 된다는 거고요. 그 다음에 세 번째는 이제 만약에 라지 w가 0이 아닌 경우는 이제 리미트 z가 z0로 갈 때 이렇게 라지 fz로 나눈 거 스몰 fz가 이렇게 되고요. 요거를 이제 계산을 하면은 스몰 w0분의 라지 w0 이렇게 나옵니다. 이거 여러분 극한에서도 많이 했죠. 많이 해가지고 이거 뭐 다 증명하지는 않겠습니다. 네, 증명 뭐 별로 안 해도 될 것 같아요. 여러분들 실제적으로 하면 됩니다. 자, 요 사실로부터 이제 뭘 할 수가 있겠냐? 이거를 이용을 해봅시다. 그래서 application, example. 자, 우리 여러분 리미트 z가 z0로 갈 때 z 계산하면 뭡니까? z0죠. 맞나요? 맞습니다. 그러면은 이제 요 사실로부터 이제 리미트 z가 z0로 갈 때 z의 제곱은 어떻게 되느냐? z의 제곱은 이제 리미트 z가 z0로 갈 때 얘는 z 곱하기 z로 생각을 하면 되죠. 그러면 이쪽에서 라지 f도 z로 넣고 스몰 f도 z로 넣었죠. 요 계산하면은 각각의 z 제로 가니까 제곱이 나오죠. 자, 이런 식으로 해서 우리는 어떤 결과를 얻을 수 있느냐? z가 z0로 갈 때 z의 n승 계산하면은 z0의 n승으로 된다는 사실을 이제 우리가 기납법 형태로 얻어낼 수가 있고요. 요것을 더해서 그 다음에 이제 2번, 1번과 2번을 조합을 하면은 요 사실로부터 우리는 저기 할 수 있습니다. 일반적으로 in general we also obtain so we also obtain the limit 이렇게 z가 z0로 갈 때 상수 a0 플러스 a1z a2z 제곱 딱딱딱 그래서 일반적으로 an의 z의 n승 요거를 어떻게 뭐가 나옵니까? 계산을 하면은 a0 a1 z0 a2 z0 squared 있어서 an z0의 n승 이런 식으로 이제 계산이 되겠습니다. 했죠. 요 1, 2, 3 프로퍼티는 증명을 안 하지만은 이제 증명을 안 해도 이제 요거 여러분들이 이제 우리가 극한하고 할 때 굉장히 많이 사용되기 때문에 이거 증명하려면 이제 에플론 델타로 나가야 되는데 그러려면 또 시간이 좀 걸리죠. 그래서 이제 요거는 증명하지 않고 넘어가겠습니다. 그래서 요번 강의는 요걸로 하고요. 요걸로 하고 우리 다음 강연은 이제 우리 그 스테레오그래픽 펑션 그 극한의 역수행 부분을 또 공부하겠습니다. 자, 수고하셨어요.